point. And the homework points and the exam points are the same thing, so it's a big chunk of the grade. And so make sure you turn in the homework. For this, for the first assignment, what I'll probably do is I'll post the grades up, and then I'll give you an opportunity to turn these in without any late penalty. But for future assignments, there is a late penalty associated with it. I need to see what you have done on the day of the exam. But for this one, if you haven't completed all of it or completed it yet, you still have a chance to get it. And so there are 3 homeworks, so it's 30 points. The exam itself is 100 points, so it's, think about that. All right, so we need to write the names. Br minus, what's the name of that? Now, that's what we call an anion. And so I haven't talked about anions yet. So let's talk about the monatomic anions next. All right, for the anions, what we do is just change the ending. And so if it's Br minus, then you probably know what this is already called. This is bromide. And so we just use the IDE ending. And it tells us this bromine with a negative charge on it, bromide. You probably know this one, Cl with a minus charge. We call that fluoride. It's chlorine fluoride. So Br minus, we call that bromide. B8, that's supposed to be Ba2 plus. The positive charge is missing. That's called barium ion. Oh, what's the formula for the potassium ion? Okay, now this gets a little bit more tricky because there are 2 ways you can do it. You can just memorize these outright. We could memorize it outright, or we could use the periodic table to tell us. If we use the periodic table to tell us, this is it. We need the, let me bring up the periodic table here. Need the periodic table again. The first column here is fixed. These are +1. These are for monatomic ions. The second one is +2. The third one here, these are +3. Okay, and then these are what we call variable charge. Beyond that, variable charge. Variable charge means there's more than one charge, and it becomes a little bit more tricky. And then we go here, the first row here, this is +3. The second one, we would do +4 in parentheses here. When we get to about this point, we can go either plus or minus. And so, or -4 in parentheses. And the next one is either going to be +5, which is getting less likely, because the higher the charges get, the less likely it becomes, or -3. And the next one is going to be +6 or -2. The next one is going to be +7 or -1. And finally, these don't form. The Nobel gases don't form ions. Or stable. Stable meaning they don't tend to lose electrons or gain them. And so, you know, the real common ones are -2, -1, -3 are common. +4 is getting too big. -4 is getting too big, but still it could happen. +5, +6, +7 is starting to go. But +3 for sure is no problem. +3 is tricky because it occurs different. And so we have this. This is called the main group, right? The main group. The main group is not completely separate, because if you look at this, take a look at how the metal bites in. You know, this block here is the main group, this block here is the main group, this block here is the transition metals. If you look at this blue region cuts in here. And so what we say is this. After the first transition metal, these are what? Plus 3. Plus 1, plus 2, plus 3. But the plus 3 also jumps all the way over here. This is also a plus 3. We skip this big block here. All right, then it becomes what? Variable charge. Now the variable charge digs into this. And so even though I said this is plus 3, this is variable charge down here, down low. You see it? And so the variable charge cuts in here. Yeah. And so the variable charge region bites in to the main group here. So there's a bit of overlap like this. So the first question, if we want to know the potassium ion, we have to determine, is that fixed charge or variable charge? It's fixed. And what is the charge?
1 + 1.
Yeah. And so potassium's K. Fluoride, is that fixed charge or variable charge? You could also see, you see these numbers I have here, like +7? Yeah. If you go back to the periodic table, take a look at fluorine here. What group is it in? There's this number here. Do you see it's 17? 17 here. If you look on older periodic tables, you'll see a Roman numeral 7 above that. Let's take a look at a periodic table really quick here. I have it up here, but it's buried now. Let's take a look at it. Do you see this Roman numeral? 7. Main group, they give the letter code A, 3A, 4A, 5A, 6A, 7A, 8A. For the transition metals, they give the code B. So this is 3B. So we have 2 3s. We have the 3B, so scandium, yttrium. Scandium, yttrium, these are always +3. And then we have the 3A, aluminum, boron, these are always +3. And so just to emphasize that, this is called 3B, well, 3A. A are the main group, B is transition 1. So fluoride, well, one thing is the IDE ending tells me it's fluorine with a negative charge. Is it fixed charge or variable charge? Fixed charge at -1. Fluoride would be F -1. There we go. So this is variable charge. Some elements have variable charge. So the first sentence. Most of these elements are transition metals, but they also bite into the main group. You know, the blue region that creeped in there. To distinguish among these, the magnitude of the charge is written as Roman numerals. So for example, iron with a 2+ charge, iron, no, there's no space here. It goes iron, open parentheses, 2, Roman numeral 2, close parentheses. This is all one word. And we treat it as all one word, iron 2. The iron 2 ion. So iron's in the variable charge region. Except, you know, in this variable charge region, the variable charge region is mainly in the transition, but it sneaks over here. So for example, lead. Lead's over here, but it's variable charge. Lead can be +2 or +4. But in this variable charge region, there's an island of fixed charge. The island of fixed charge is this. It's going to be Zn, which is always 2+, cadmium, which is always 2+, and silver, which is always plus. This is a little fixed charge island in the sea of variable charge species. These you have to memorize. And so this is a little L of fixed charge. Zinc, cadmium, and silver. So iron is, if it loses 3 electrons, then it's going to end up with 3 missing electrons, which means 3 of the protons aren't going to be, 3 of the protons in the nucleus aren't going to have a negative charge to balance it. Of course, iron 3. There's iron 3 ion here. Special cases, this is what we call a diatomic ion. It's a 2-atom ion. So we have 2 atoms of Hg. What is Hg? Mercury. And so this is called diatomic, but the name is kind of funny. We don't call this dimercury ion. You'd like to call it dimercury, right? Because it's 2 atoms. But we don't. We call it mercury 1. Now, why do we call it mercury 1? Why isn't it called mercury 2? Because, you know, you got 2 and 2. It should be 2 here, but it's not 2. It's not 2 because the Roman numeral represents the charge on a single atom. So if you have 2 atoms and the total charge is positive 2, then that means each atom must be plus 1. And so this is why it's called mercury 1. This one you have to memorize. And so we do have to memorize some polyatomic. These are called polyatomic cations. There's one more that you have to memorize. Atomic cation. There are lots, but there are 2 that you need to memorize. One is Hg2, 2+. This is called mercury, Roman numeral 1. Mercury. The other is this one, NH4+. This one's called ammonium. So NH4+, ammonium ion, and Hg2, 2+. All right, now let's take a look at the names of this. Here's 2 Mn. What's Mn? Is that magnesium or is that manganese? Magnesium or manganese? Manganese. And so the first one, is that variable charge or, well, obviously it's variable charge because we see 2 with 2 different charges. Variable charge. And so the first one we're going to call manganese, Roman numeral 2. And the second one is manganese, Roman numeral 3. And so those are the names, but they're also called manganese and manganic. Which one do you think would be manganese? 2. Yeah, and manganic would be 3. Nickel 2 is also called nickelus or nickelic. Yeah, and nickel 3 would be nickelic. So we got manganese, Roman numeral 2, all one word, manganese, Roman numeral 3. And then for nickel 2, it's nickel with a 2+, and for nickel 3, it's a nickel with a 3+. So the other polyatomic cation would be ammonium. However, we have lots and lots of polyatomic anions, lots versus monatomic. Then the polyatomic anions, we memorize these. So when we see the "ide" ending like this, the "ide," that usually refers to monatomic. Monatomic. This usually refers to a monatomic anion. Like example, chloride. Cl minus. Except for these. Hydroxide. Is there, you would think that, you think, oh, okay, hydroxide, that must be hydrogen, right? As an anion, but it's not. Hydroxide. Hydroxide, you have to memorize it. Hydroxide is OH minus. Note, what would H minus be called? H minus is not called hydroxide. H minus is called hydride. Like nickel metal hydride batteries or something. It's hydride, not hydroxide. Hydride, monatomic, hydroxide, polyatomic. What else do we need to know? Except for hydroxide, these are polyatomic ides. Polyatomic ides. So we need to memorize the polyatomic ides. Hydroxide. So when we look at the, etc. When we look at the polyatomic anions, polyatomic ions, well, let me just redo it. Polyatomic ions. For the cations, it's easy because we have so few. What are they? NH4 plus, which we call, and Hg2 plus, which we call mercury. This is called mercury. What was this not called? Mercury 1. Note, Hg2 plus. Is that polyatomic or monatomic? Yeah. And do you know what the name of this is called? Mercury 2 ion. But that's monatomic. And so for polyatomic anions, there aren't that many that you really have to worry about. But for anions, there's lots. And so the anions, we get a clue by their ending. So for example, if they end with "ide," normally we automatically think it's monatomic, but there are some polyatomic ides that we have to worry about. And so what are they? So for example, OH minus is called hydroxide. What else? Cn minus. Cn minus is a carbon and a nitrogen. This is called cyanide. Cyanide. O2 2 minus. O2 2 minus is called peroxide. So let's see which ones are good to remember. I didn't bring my manual here, but let's see what the book shows as far as ones to memorize. I'm going to jump ahead to see their chart here. All right. Cyanide. There are a whole bunch of others, but they aren't that important. Like, let's see, hydroxide, cyanide, peroxide. I'm missing. Well, if I can't remember, I haven't used it in a long time then. Actually, I remember. So we have the I's. It'll come back to me. And then we have the what we call the eights. The polyatomics that end in ATE. And the polyatomics that end in ATE, we have two ways we do it. We have ones that we can get from pattern, from the periodic table, and others that we just have to memorize. Just raw memorization. So the ones from the periodic table, this just helps cut down the amount of memorization you have to do because there's a certain pattern with the eights. And so, for example, if we look at the periodic table, starting with boron, and then just go across here. And so boron forms a polyatomic that has one boron and 3 oxygens. And it has a 3- charge, and we call it borate. And then what's next to boron? Carbon. And then carbon has a C with 3 oxygens, and the charge is, I think our book goes through this as well. What's the charge on it? 2- is the charge, and we call it carbonate. And then after carbon comes nitrogen. We have nitrogen with 3 oxygens and a negative charge, which we call nitrate. And then we have an oxygen here, but we'll leave that blank here. And then we have chlorine here. We have something called FO3 with a minus charge. We'll call this fluorate. Do you see a pattern? Yeah. Group 13. So group 13 or 3A begins with boron. And what's the pattern? They all have 3 oxygens. Take a look at what happens with the charge. You see a pattern in the charge? They're all negative charges, and it goes, what, 3, 2, 1? And then we go to fluorate, it stays 1. And then, can you guess what chlorate is going to be?
1.
Can you guess what chlorate is going to be? Cl3-. You got it right. That's chlorate. And so if you know a pattern, then you're much more likely to be able to predict things rather than people who don't know a pattern. But we need more data. And so bromate, what's bromate? Br, you probably can guess, bromate is BrO3. Negative. Yeah. You'd be right. This is bromate. And what would the next one be? Tell me what the next one would be, following the pattern. Next one is I. What would it be? Okay, it would be IO3 negative, and we'd call it no. Iodate, yes. That's iodate. See? So it's nicer to be able to figure things out rather than having to write flashcards for this. I mean, if you know this pattern, how many flashcards could you save? A lot. But you do have to memorize. You know, I memorized 1. I only memorized this one, and all the others I can figure out easily. So I have 1 flashcard instead of a lot. Okay, this is what we call the outer band, and then there's an inner pattern to this. An inner pattern to this, since I'm running out of room, I'm not going to write it down here, but the inner pattern is anchored by this. Actually, I'll just write it here. Silicon. What do you think, if carbonate is CO3, 2 minus, what do you think silicon is going to be? I would think SiO3 2 minus, but it changes. So we have this outer pattern, and then we have this inner pattern, and it's different. Silicate is SiO4 4 minus. This is group 4, 14. And so we have two patterns, two separate patterns that we recognize. This outer pattern here, and this inner pattern here. This inner pattern is going to begin with silicon, so I've memorized this one, silicate ion. If you're a geologist, then silicate is a very common species, making up a lot of the rocks and minerals. So that's silicate. SiO4. Under nitrogen, do you know what's under nitrogen?
Phosphorus.
Phosphorus. And you know what we call this? PO4, 3 minus, and we call it phosphate. Okay, below oxygen comes sulfur.
Sulfate.
Sulfate, you're right. That would be sulfate. And what's the formula for sulfate?
SO4 2 minus.
SO4 2 minus. And so here, by using this pattern, we can make some predictions. So for example, below phosphorus is the element arsenic. And so what would arsenate be? ASO4 3 minus, and you'd be correct. ASO4 3 minus is right. Below sulfur is selenium. So what would selenate be? SeO4 2 minus, and you're right again. And so if we know a pattern, then again, it's going to help us minimize the amount of memorization we have to do. But unfortunately, it doesn't eliminate the amount of memorization because we still have to do some memorization. This is the inner block. In fact, it germinate. You know, below silicon is the element germanium. Germinate would be Ge. How many oxygens would you get?
4.
GeO4.
4 minus.
4 minus. That would be right. Germinate. Okay, the next thing we're going to do is we're going to look at the ones that you have to do raw memorization for. And so here, what do you want to memorize for the periodic table? You memorize borate. I memorized 2. Memorize borate and silicate. So that's where the pattern begins. Borate and silicate. The others that we just have to memorize outright are ones that end in 8 that don't fit this pattern necessarily. And so common examples of that would be, this is a common ion, CrO4 with a 2 minus charge, it's called chromate. Cr2O7 2 minus is called dichromate. MnO4 minus, this is called permanganate. There are more. C2O4 2 minus is called oxalate. Chromate, dichromate, permanganate, oxalate. What other 8s do we have? These are less common. I don't know. I'm going to make you memorize it. CNO minus is called cyanate versus cyanide. CN minus. Okay, then what we do is we go on to this. So that's the 8s, and then we have the I's. The I's. The I's I don't memorize. Well, not I's. Ites. All right. The Ites I don't memorize. ITEs. Ites, I don't memorize them because it's easy to figure them out. One less oxygen, one less O, same charge. So for example, nitrite. What is nitrite? Nitrite. Oh, well, if you know nitrate, then it's going to be NO2. And the charge? There might be some more. I'm going to look at the list. Okay, that's the ites. And then we have the what we call the per-8s. The per-8s have one more oxygen than the 8s, same charge. And so example would be perchlorate. What is perchlorate? Well, we know what chlorate is. What is chlorate? And therefore perchlorate is ClO4 minus. Those are the per-8s. And then we have the hypoites. So it's hypo prefix, hypo, and then ite suffix, the hypoites. And so what would hypochlorite be? Hypochlorite. And so hypoite means one less oxygen than the ites. Same charge. So hypochlorite. Hypochlorite. ClO2 negative is incorrect. You know what we call ClO2 negative? What would ClO2, what would the name for ClO2 minus be? ClO2 minus is not called hypochlorite, it's called probably this is the easiest way to see it. The easiest is, what is chlorate? Not one you have to know how to derive. Chlorate is, okay, what is perchlorate? What is chlorite? ClO2 minus. What is hypochlorite? Hypochlorite is ClO negative, 1 oxygen. If none of this makes sense, then do the flashcards. You know, just make a whole bunch of flashcards and start memorizing. The important thing is to start memorizing, however, whatever way works. You know, and some people don't like this method. Some people like this method. I'd say, you know. Past Chem 4 classes, the majority of students didn't do the pattern. The majority of students just did raw memorization. It's up to you, whatever you want to do. All right, now we're going to write the name of ionic compound. So first we got to be able to name the ion. So to do the ionic compound name, we just need the name of the cation and the name of the anion. That's the name of the ionic compound. And so this slide has been long. You just name the cation and then name the anion. That's it. And so the easiest way to do this is just by examples. We just do a bunch of examples. Ammonium bromide. And so what's the ammonium cation? Well, you know, the first is the cation name. So if we're looking at naming or writing formulas, so ionic compound comes next. And so if we look at ammonium bromide, then the way ionic compounds are named is the cation goes first, followed by the anion. And so what is the formula for the ammonium cation? We haven't memorized. NH4 plus bromide, Br negative. And so we put these together. We got to make sure the charge is balanced by changing the ratio. So charges, make sure that the charge is balanced. And so when we add it together, it's just ammonium bromide is NH4Br. It's balanced, 1 to 1. Okay, ammonium sulfide comes next. So what is sulfide? Go back in your notes and take a look. What is sulfide's monatomic sulfur? What's the charge on it? Most ides are monatomic, unless you've memorized it as being polyatomic, but there's so few polyatomics. Hydroxide, peroxide, cyanide. And so it's sulfur with, what's the charge, the negative charge? Negative? Yeah? Actually, it's -2 or 2 minus. And so, will one ammonium balance out that? Well, no, we need 2 ammoniums to balance out the -2 charge. And so if we show it like this, does that look right? No. What we have to do is we have to make sure that we show that we have 2 ammoniums, not 42 hydrogens. And so this would be the formula for ammonium sulfide. 2 ammoniums to every sulfide. Two ammoniums to every sulfide. That's to balance out the charge, the positive and the negative charge. Aluminum oxide and barium nitride. All right, aluminum. What's the charge on aluminum? 3 plus. Oxide, monatomic oxygen, likes what charge? We have too much positive, not enough negative, right? And so what if we put another oxygen here? Then we got -4 altogether and +3. And therefore we need another aluminum. If we do another aluminum, is it balanced?
No.
We'll need one more. And now it is. +6 -6. And so that's going to give us Al2O3.
3.
Okay, we're out of time, so we'll continue this next time.